geomapping. So what is geomapping in Tableau? Geomapping is used to plot your geographical data on your Tableau charts. If you want to analyze your data geographically, you can plot your data on a map inside Tableau. So this portion of this course will explain you how and when and why you should put your data on your map visualization. It also describes some of the types of maps we have and we can create inside Tableau. There are many reasons to put your data on a map. If you have some location data on your data source, or maybe you think a map could really show your data very well, this can be a good reason to create a map in visualization. It's important to keep in mind that maps, like any other type of visualization, is showing your data perfectly. You can go with the different map. You can make a map in Tableau because you have some kind of question where the data is totally related to the question, is totally related to the map data, and you have to use your map visualization to understand the trends and patterns inside your data. So what can be that some kind of questions are like, which state has the most farmer markets, and what are my regions where my sales are going high or low, or common questions like okay, where is my rainfall more, or where are we seeing more fires in a forest, kind of questions you can actually answer based upon the map visualizations, because it will show all the parts in particular geographical part like content. It will throw all the answers related to that particular space. You can plot your data onto the map. So Tableau is actually designed to make the most out of your geographical data. So you can answer the questions like where and why, etc. So based on this geocoding and whatever latitude and longitude points we are getting from the data itself, Tableau will pick up automatically that location data and it will plot the data according to the points. So the information you already have will show this interactive map. Whenever you zoom the content also, you can show according to your points you get from the geographical data. You can simply show this visual map visual and to the business advisors, and you can simply explore the data and show what you find in your data, like insights to the final users. You can even import the geographical data. Sometimes you can even import the file separately and play with the visualizations and create more accessible interactive visualizations out of the map content. So the next one in this map space is geospatial mapping. We will see what is geospatial mapping inside Tableau. So the spatial functions, they allow you to perform this spatial analysis. So these visualizations focus on the relationship between the data and its location to create a visualization or an insight of it, of like any data point you have, you can create the insights out of it. So any positional data works for this spatial analysis. So what makes this geospatial visualizations unique is the scale out of it. Like a diagram of circuits on the microchip explores position, but that's not a spatial data, but if it has a location content and you're exploring the spatial distance between them, you can see that it is a spatial data. So it does not map to that or any other planets. Like a map of the stars is not considered as geospatial, but a map of a surface of Mars is, let's say, because that has a points of latitude and longitude on the Mars. So this geo visualizations overlays variables on a map using this latitude and longitude to create these insights out of the map content. So these maps, the primary focus of this geospatial visualizations, they range from depicting a state, town or a park to show the boundaries of a country or a continent, or you can even say the whole planet. So they act as a container to extract the data. This allows you to create context using these shapes and color to change the visual focus, but they help to identify the problems, such as they can track change, they can make you understand the trends, and they can even perform forecasting related to specific places or specific times. So these geospatial visualizations highlight the physical connections between two data points. You can create a line to connect to these two data points. Just say one is origin and one is destination. So you can just connect these data points and create an insight out of it. So when we will choose this geospatial visualizations, like if you want to depict the space or distance or create an outside based on the origin and destination points, these geospatial kinds of maps show you a solution for these questions. So we have two kind of formulas, let's say the logical analysis, let's say spatial analysis kind of inside the geospatial data. One is make line and one is make point. So make line will calculate the line between the geometry 1 and geometry 2. Let's say it generates a line mark between these 2 points, useful for building like two origin destination maps, and it will draw a line between these 2 points between origin and destination. So that the second one is make point. So make point is between the latitude and longitude. This data converts from latitude and longitude columns into the spatial objects. So this one will convert the data from projected geographical coordinates into the spatial objects. So this one will be readily, like easily available for your data whenever you have this latitude and longitude points available, which will be defaultly coming up. Tableau picks up the regions well. They will show you this latitude and longitude well, and it will depict this whatever columns into the spatial objects. So when are this geospatial data, like we find them important? Why we use this geospatial data? So some of the use cases, like the common use cases, let's say the general ones, like what are the countries suffering from the most of the earthquakes, and which part of country does it rain the most. We already discussed this example. We can actually show which part of the country is suffering most, and this is an important one, which airport encounters the most traffic during a holiday season, and over the course of a year where does a bird migrate during rush hour. What is the quickest route from point A to point B, like just like our Google Maps, and it will also show what are the alternate ones and what are the crowded routes whenever you're traveling. Just imagine this kind of questions might come in geospatial data, which in the real-time scenario we might see some projects totally related to the just geospatial content, but we do have some projects coming up on the geospatial data as well. Like relate these kind of questions to this map content so you will understand what is geospatial data used for. What are the standard maps available in Tableau? And we do have some maps inbuilt inside Tableau, and what are they? So the basic maps in Show Me is two types of maps. We have a filled map where the entire color is filled on the entire proportion of that area, and we have a simple point map which shows whatever measure you're showing there, it will enlarge based upon that point map, and it will show you how it is looking up based upon a value. But we do have different maps in Tableau. More than the standard maps, we can even create some maps which are more complex, and more it will throw you more insights. So this is like a simple map you get of, like just a pointed map. Just to the right side of our image we're seeing a pointed map. We can call it as a simple map showing the value on that particular state, and we can create maps from spatial files. Spatial files are the files which has the data of all the analysis of map content. Let's say a latitude or longitude kind of data. It has all the access. It has all the points already mentioned in that file. We can call it as a spatial file, and we can build some proportional symbol maps. Proportional symbol maps are the maps which show you whatever shape you wanted to show on the map. You can even show different shapes, and how are the shapes looking on the map whenever it is compared to the other regions. So this is completely based on the quantitative values, and proportional maps are great for showing these values with individual locations. They can show one or two quantitative values per location, and it will be encoded with size or encoded with color if necessary. For example, like you can plot earthquakes recorded from different years around the world, and you can show them in based upon the size of the magnitude. This can be an example of the proportional map. That means based upon the size of the whatever shape you're showing there. And we have point distribution maps. Point distribution maps are great for showing how locations of your data points are distributed. So this one will explain you how to create a point distribution map, and this one, let's take an example of points, like all the content you have on the map. Let's say, where are my products coming from, like which part on the map are my products coming from, and you will get a point on each map. Okay, I'm having this, just compare this whatever map you're seeing right now, this America. I have all the products coming from maybe east parted, but the west part is kind of looking empty. It will throw the dotted points everywhere, and you can call this as a point distribution map, because points are distributed all over your map, and you can see the density of points whenever the data is covered the entire east region and the west region. You're seeing a simple dotted points on few areas, and you can just by seeing that you can say, okay, all my data points are coming from the east but not west, something like that. You can relate to that. And we can create heat maps. Heat maps show the trends or density inside the Tableau. They will reveal the patterns or the relative concentrations that might otherwise hidden due to an overlapping mark. So these types of maps are called heat maps or density maps. Tableau will create a heat map by grouping overlaying marks and color coding them based upon the number of marks in a group. So density maps will help you identify locations with how greater or fewer number of data points. Density maps are most effective when working with a data set containing many data points in a small geographic area. And we have a field map. You're also seeing the field map on the image right now. These are also called choropleth maps. These are best to show the ratio or aggregated data for polygons. So these polygons can be countries, regions, or states, or any other region. You can be geocoded in Tableau. They can even be custom territories. We will talk about custom territories, how to build them inside Tableau. They can be showing that. And these types of maps are called choropleth maps or filled maps. You're seeing one on the screen, and this one will be created according to the polygons or the aggregated data. Let's say to that particular space, the aggregated data is that complete field value. And we have a flow map, which is also called path map, and we have origin destination maps, which can be created from geospatial content, which will use the formulas of make line or make point. We will see some dashboards which has that data, and this one or origin destination maps are called a flow map, path map, completely dependent on the data what we have. We can create this. So we have a dual axis layered map. That means we can plot different layers on the maps. We will see what are the map layers also, and we can even plot layer by layer map on the content whatever you have. To compare it with a different layer, we can plot the base layer to one and compare with the different layer. We can plot one more layer on the top of the current layer. So the last one inside the Tableau will be a filled map, but we can even show some pie charts over the filled map to show more data, like to show more cuts. We can even throw some pie charts on your filled map you have over here. Let's just take this example, and we can create a dual axis and create a pie chart and throw a pie chart over the whatever the filled content you're seeing right there. That can be the map which is filled map with the pie chart map. You can show two different visualizations on the same map. So this is all about what is a map, what is a geo mapping, what is a spatial mapping, and what types of maps are available in Tableau. Let's quickly go, we will go to our tool and can build these maps inside Tableau. We are connected to the full data of our practice file. We have a latitude and longitude pointed in this data set already, because we have some geo columns in our data set. Let's take the example of state or the postal code. It is showing the map symbol for that, and this is saying that we have a city, we have a country, and this is saying that you have some map related data on your columns. You can use them for some map related data, and this will throw you latitude and longitude because Tableau automatically recognizes that you have some map related columns inside your data. Let's take the example of city or state or postal code. From that, it will grab the latitude and longitude automatically. If you have them manually inside your data, that's completely fine. You can pull them too. But if you have the geo mapping data inside your columns, Tableau will automatically do that for you. No, not a problem at all. So right now we will just go with some simple maps in the start, because we wanted to see how the show me works. We have like two kinds of data. One is this and one is that, the filled content and the pointed data. Let's see how those simple maps will work. And for that, what I will do is I will just create a map content by just clicking on the state. Just double click it and the state will come up onto your view, and it will automatically point out latitude and longitude out here. Right now it is not showing anything because it did not recognize a location of your let's make it to US, and it will recognize the states, because the content we have it here is for US, and that's why I did not. So if you just repoint the values to the content, it is right now United States, and this one is a simple pointed map. All the dots you're seeing over there represents a quantitative value. So if you want to show some quantitative value out here, you have to add some measure. Let's say a measure value should be added to your map, because whatever dots you are getting should be based on some measure, right? So we have state in a detail, that's why each dot is related to each state. And I'm just double clicking on the sales. So sales will automatically point out to the size mark. So this size mark will be bigger based upon the value it has inside. If you see here, if you just make it into a bigger size, so this is a map, a simple map, basic map you see, and the dots you're seeing here will be completely based upon your quantitative value. In this scenario, it is sum of sales. The sum of sales is represented according to the density of that circle. And if you see here, it is allocating each value to each density, 920 this one, 1 lakh this one, 2 lakh this one, like that. So the round size will come according to your quantitative value. And you can even fill this up into a filled map like this. So this is a completely filled map, and you can add a different hierarchies also here. You can even drag the country over into the detail, and you can see here the country and state coming up. And this is a field map. If you want to convert your map to other maps, you just have to go to show me and click on this field map. So what is the difference between the previous field map and this field map is whatever measure one you are using is placed on the color, and this color will be allocated according to the value. If you see here, the color mark is being assigned to sum of sales, and if you see here, different kinds of blues are coming with different kinds of quantitative values, and this one is allocated to each value, and you can see it over here. These are the two simple basic maps which are available in Tableau. You can even switch on the labels and it will show you what content it is there, what value it has inside, what is the quantitative value, why is the color dark blue, and why is it light blue because of the value, and you can show everything on the map. Maps are the best way to visualize your data whenever you have a spatial question, because that one will answer your data right away based upon the location. Because if the customer wants to see where are my sales going up high based upon your region, this can be a best way to show him right away based upon the color mark. This is completely based upon the thumb rule. You have to ask yourself how fast your visualization is going to answer the question and how easier it will be to understand the data, whatever you're representing. So based upon that, you can switch to different charts. You can point out the same data in a bar chart, but is it going to the final advisor? Like, is he getting the most out of it, most out of your data? How is the best way to represent whenever there is a question based upon region or a state or a postal code, etc.? So if your answer is as okay, I'm going with a map, then perhaps a map view is the best visualization you have to use out there to convey your content to the final user. This is all about the basic maps available in Tableau, and whenever you have content related to the geographical mapping columns you have inside Tableau, you can take that data and create some basic visualizations available on inside your Tableau. But we also have some special visualizations we can do with the geospatial data. Right now, I can show you some example where the geospatial data is mostly useful. If you see here the visualization what we have in Tableau gallery, there's one visualization which is stating out the finished flight paths, and it is throwing up the lines between each point to each point, and this one is using the formula make line because the geographical content is having the spatial data, and it will show the line based upon the origin state and the destination state. So it will pick up that latitude and longitude. So from whatever it is, like, see, if this line is actually pointing out the origin is Jakarta and the destination is a Mexico City, and it will show you the line between these two states, like origin and the other one. And if you see here, it has the data related to the spatial analysis. If you want to look at the data inside, you can go with this view data content over here. And if you see here, the destination is Mexico, origin is this city, and they used a make line value. It has the latitude and longitude points to create that line between two points. So this one will show you the distance between each state, and it will throw you what are the completed flight destinations between two points, and they gave us some filters to select the origin state, so we can actually point out all the destination states going to state New York. And see, if you see here, New York has this flight completed destinations, like completed flight paths from New York to different states. This is going to Fremont, this is going to Los Angeles, and this is going to Austin. And you can see the lines pointing out from the origin to destination. So you have these many flights, you have available flights for these states. Maybe the question was what are the flights available from origins to New York to different states, what are the flights available, and if you see here how it is throwing up onto a different origin, and you can also point out the flight timing and also the destination timing, so that you can say, okay, these many hours it will take to actually fly from here to here. If you have the data, you can point out these things as well, and you can show the destination, timing and everything, and show the people how long the journey is going to be, all these scenarios if you have the data, like I say. And you can point out different values from different states. If they're interested, they can actually select with a different state coming up here. So okay, some other state, and this only has one line that is saying that okay, there is only one flight data we have for this state. This is how this geospatial data will look like, to make the lines and to point out to different origin and destinations. And geospatial data is rare. I'll be completely saying that you will get the rare scenarios to point out geospatial data, but it is a good point to know these are going to work, and data points to make line, make point values. It's just a simple formula. You just have to tag latitude and longitude. That's it. It will throw out a point for you. So this is about geospatial data, and we have different kinds of maps available. We can create different kinds of maps whenever you're going with the maps, and to actually throw some layers, like we have talked about throwing some pie charts are available on top of our layer. So how can we do that? For that, what I will do is I will just drag longitude and latitude again on my visualization. Actually, why I'm dragging latitude and longitude is the points should be syncing up on the map. So we are creating one more layer to build a pie chart on our already existing map data, right? So for that, what I will do is I will to sync up the points, I'm just throwing up the latitude and longitude again to get that point on the back point, whatever base layer you have, it should be on the same point. So what if I say I'm creating a pie chart in my second value? So the second mark card is here. So what I did is I changed my my visualization to a pie chart, and what I will do, I'll say sum of sales to the angle and sum of sales to the size, let's say, and I wanted to show according to let's drag category onto our view. So I will just do this. What I did is I dragged category into my color, I dragged sum of sales into my size, sum of sales into the angle, which will create an angle to the pie chart, and this is how you see a pie chart on the map layer. And we also have a filled map over here, right? So what we have to do is we have to sync up these two axes. So for that, I'll be syncing up dual axis. So the latitude and the longitude, for now I'm switching up the labels, so it will show up the size, how it is looking like at the back. So right now we are seeing a pie chart, on the layer of our mapped chart. This one is how we create a dual axis for a pie chart. The second one is a pie chart and the first one is actually a map, and this pie chart is overlaying on the map chart. For that, I just created the latitude and longitude again over here, so that the pie chart will be placed on this particular area. If you want to see here, whatever the pie chart is showing for is for California. That means that this pie chart is totally related to only California. The 4,57,000 what you are seeing here is distributed according to the category on this pie chart, but this complete value is totally related to the state California, and this pie chart is hovering on that particular point. For that, we have created this longitude and latitude points in the rows and columns, and the second one should be pie chart, which should be hovering on your fill map. This is how you can create layers and layers. You can actually go with different kinds of maps over here. You can create a shape content, or you can create a density or a polygon also. But based upon the data or based upon the requirement, it is better to see which one fits the best. So in here, I just showed how to create a pie chart. It can be any other thing based upon your data. You can create or a polygon map, but you have to check whether it is fitting well. It is showing the right value over there. Is it showing the visualization looking good, better, or something like that? You have to check the data and then decide upon what visualization you're going with. And this is how you just layer up a different visualization on your filled map, and you can show whatever text labels you want it to show, but do not make it cluttered, and remove whatever that is not necessary and keep the map simple. If you're showing this, you have to be so keen about the whatever clutter you have on the label values also. So that one is the one thing to remember whenever you're creating layers on your maps. So this is how we do layers on the maps, and with the dual axis, let's say, and but what we did is we created latitude and longitude again to create the dual axis.